In this video, we're going to see what happens when a problem gives you a percentage and you need to find an x-axis value. So this is the 2018 ACT scores are normally distributed with a mean of 20.9, so that went right in the middle, and a standard deviation of 5.6. So that's how I created these values that are 1, 2, 3 standard deviations above and below the mean. Oh, there should be one more. What was it? 4.1. I guess it got deleted. So that one's there. Now this says what scores cut off the top 20% of scores. Now until now, we would be given a score and we would be asked what percentage of test takers scored above that or below it. But now we want our answer to be a score. Like what score cuts off the top 20%. So what we want to find out is the score. So what value here where this area is 20%. So the area is 0.20 and we want to find that score. So it's probably going to be somewhere between like 26.6 and 32, but let's find out for sure. So what you're going to do, instead of looking at the outer edges of the table, you're going to look in the table and try to find, well, you know how the area is always to the left? So we're going to try to find 0.80 on the table. Let's see, 0.80, somewhere on the positive side. It's going to be above the mean. Here's 0.81, 0.7852. Here we go. And you're just going to find the number that's closest to it. Like if you picked 0.7995, that's fine too. And so it's going to be a z-score of 0.85. So this z-score is 0.85. But I want to translate that into a ACT score. So I know that z-score comes from doing the observation minus the mean divided by the standard deviation. So this 0.85 comes from the value I'm trying to find minus the mean divided by the standard deviation. I'm going to multiply both sides by the standard deviation. So 0.85 times 5.6 is 4.76 equals x minus 20.9. I'm going to add 20.9 to that, 20.9. So an ACT score of 25.66 is going to be the answer. So 25.66, you don't have to round. Okay, so that's right here, so that adds up. That looks right. As far as it cutting off the upper 20%. So you know how you're told, oh, you're in the top 20% of your class. Well, if you got 26 on the ACT at 27, you're in the top 20% of ACT scores. What score cuts off the lowest 30? So the lowest 30, I'm just gonna shade in 30% of the area. And you can better approximate where that's gonna be because you know the empirical rule. And I want to find this z-score, and the area to the left is 30. You always want the area to the left because that's what the table gives you. So we're just going to look at the table and look for the closest number we can get to 0.3. That's going to be here, 0.3085. I think so. Okay, so that's negative 0.50. So your z-score, negative 0.5. So we used to do questions that would be like, hey, you have a z-score of negative 0.5, what percent of values will be lower than that? And you'd say 30%. But now you're given 30. What z-score cuts off that lowest 30%? So it's like going in reverse. So let me write that neater. But I don't want the z-score. I just have to convert that to an actual value. So I'm going to do the same thing I did above, where my z-score equals my ACT score minus the mean divided by the standard deviation. I multiply negative 0.5 by 5.6, and I get negative 2.8 equals x minus 20.9. I add 20.9, and I get an 18.1. So 30% of scores are less than or equal to a score of 18.1. If it ever asks you about a percentile, remember that's the percent of values that will be less than or equal to it. So the 90th percentile means that 90% of values will be less than or equal to that score. So when they give you a percentile, they're also giving you an area. This area to the left of the value I'm trying to find is 0.9. I can look at my table for 0.9. Hunt for that. Here's 0.9. Here we go. 0.9015. That's as close as we're going to get. So that's 1.29. So this z-score is 1.29. 90% of the values will be less than a z-score of 1.29. And now I don't want that score standardized. I'm going to unstandardize by plugging it into my z-score formula and solving. 1.29 times 5.6 plus 20.9. 28.124. So if you got it 28.1 on the ACT, you're at the 90th percentile. And I think I actually looked this up. This is actual data from like last year. The interquartile range. So remember the IQR is Q3 minus Q1. Now remember 75% of the data is less than Q3 and 25% of the data is less than Q1. So you're going to find two numbers here. Q3 minus Q1. And you got to think about these areas. So this area is 75%, that's less than Q3. 25% is less than Q1. Oop, I didn't mean to write that. I meant to write the percentages. So I'm going to leave this one to you. Find 0.75 in the middle of the table, 0.25, figure out those corresponding z-scores. You have to convert them to ACT scores first, and then you can subtract them, and that'll be your answer. So that's kind of working backwards. What do you do if you're given a percentage, which corresponds to an area on the normal curve, and you need to find a z-score, which you will then convert to that unstandardized score, whatever the context of the problem is, birth weight, ACT score, height, whatever.